in the differential equation, I solved using the definite integrals. The differential equation was this: x du dx minus q squared xu equals to 0. And and we found the limits of the definite integral and also the function t, capital T. Okay, but if you put there, I just found the function t, which were written, was something like this: the some constant, some integral over some, I think t squared minus q squared, something like this. But if you calculate the integral, this integral, and find the a good function, a good representation of t, and put it here, that would be equal to some constant here, minus q plus q into the xt t squared minus q squared to the a half minus 1 dt. The power of this parentheses, let me write it here, is a half minus 1. Okay, but this is just a solution of this differential equation, and differential equations usually got general solutions and particular solutions, and this is a this is not the general solution of this, and this is a differential equation of the second order, and the general solution of that is like this. If if you find some if you find two solutions for that, say u1 and u2, then the general solution would be a u1 plus b u2. Okay, and a and b are constant. Let's show them by r u1 and s u2. Okay, but we should find another solution for that in order to find the general solution, and another solution is, I'm not gonna talk more about that, but this would be equal to, let's call it u1, and this u2 would be before that, let's here take t to be q cosine theta. Theta is a new variable, and doing this, no values of t would be missed, because the limits of this integral is q and minus q, which means that t is between q and minus q. Okay, and here cosine theta is between 1 and minus 1 multiplied by q would be this. Okay, so let's do that. That would be equal to c the integral from 0 to pi e to the qx cosine theta sine theta to the a minus 1 dt. d theta, sorry. Okay. Now, let's and the other solution would be, as I said, that I'm not gonna tell you how we could find it, but let's not talk about that. But the other solution would be equal to some constant, let's say c2 x to 1 minus a, the integral of 0 to pi e to the qx cosine theta times sine theta this sine 1 minus a d theta. Here it was a minus 1, here we got 1 minus a. And here a should be a should be between 2 and 0. Then the general solution, this is u1, would be r u1 plus s u2, and r and s are just arbitrary constants. But one thing I forgot to say, that the u1 and u2, in order this thing be a general solution of a differential equation of the second degree, should be independent. And what does that mean? Again, let's not talk about that here. But and these two are independent. But if a be equal to 1, then this should be, here we got sine theta to 0, which is 1, and here also 1, and this also would be x to the 0, which is 1. So the two integrals are not independent anymore and are just equal. Then here, in order to correct it, we write, we write them like this. Let me. And r times u1 would be r c times this integral, and let's call rc as c prime 1. So this would be c prime 1. And let's call this e to the qx cosine theta as g, for the sake of writing. G times this sine theta to a minus 1 plus s times u2 would be s c2 times the rest, and let's call the sc2 as the c prime 2. Okay, the integral 0 5 again g, and here the power of this one and this one are the same. So, and and this is this is an integral with respect to theta, so x is constant to this integral, so let's take it inside, and the product of this and this one would be x sine theta to be 1 minus a d theta. And let's write these two integrals as one integral. That would be 0 pi, and take the constants inside. That would be g c prime 1 sine theta a minus 1 plus c prime 2 x sine theta to 1 minus a, and the whole thing d theta here. Okay, now